Boyle's law states that when the temperature of a gas is kept constant and the pressure increased, its volume is decreased proportionately. In reverse, when a gas is at a constant temperature and pressure decreases, volume increases. By itself, Boyle's law is of little use because, in practice, air is not compressed at a constant temperature. Although, if we use Boyle's law in combination with Charles's law, it becomes more useful. Charles's law states that if air is heated at a constant pressure, the change in volume will vary with the change in temperature. Therefore, the volume of a mass of gas at constant pressure is proportional to the temperature of the gas, or air. So, the product of the pressure and volume of the air through each stage within a turbine engine is proportional to the temperature of the air at the stage. During compression, as work is done to increase pressure and decrease volume, there is a corresponding rise in temperature. During combustion, the addition of fuel to burn with the air increases the pressure and there is a corresponding increase in volume. During exhaust, there is a decrease in the pressure and temperature of the gas with an additional increase in volume.